In this video, we're going to talk about functions in the programming language Go. Functions are a nice way to break a big problem up into smaller problems and to create reusable code that you can use more than once to solve the same problem over again. So in this particular example here, I've created a collection of functions that are going to compute the area of simple geometric shapes, right? So the radius of a circle is pi r squared. So we've created a function here. We're calling it circle area. Now we actually capitalize that name. That means we could, and we'll talk about this later when we create Go programs that live in more than one file, we could use this and make it accessible in other packages, other files, by making it capital. If we begin it with a lowercase letter, then it would only be usable in this file. So we capitalize this circle area. The radius is going to be a float 64, and this function is going to return a float 64. So it'll compute pi times the radius times the radius. Similarly, the triangle is a half the base times the height. The square is the side squared. Rectangle width times height. Trapezoid is the average of the two bases times the height. And then the ellipse is the pi times the two radii. So here we have a simple program that will use these functions. We define circle radius to be 3. We compute circle area. We pass circle radius, and then that will become radius up here. And then it will compute the value. It'll come back. We'll go into the variable circle area. And so here you'll see that we don't actually have to define the data types for these things. We can use the colon equals, and Go will infer those data types. So it infers here the float 64, and here it infers the float 64 from the return type of circle area. And then we print out the result. So we can run this program. We'll see when we pass in the values, it gives us each of these areas. All right, so these are some pretty simple functions. They were one-liners that returned a simple mathematical expression. We don't actually have to return a value from a Go function. We don't have to make them one-liners. We can do more complicated things. So we're going to move on to another example. And this next example is going to increment the value. So you'll see here, we now have a function that doesn't return a value. So you'll see there's nothing listed after the parentheses. So there's no return value. So this one is going to try to increment a variable. And this is going to highlight pass by value versus pass by reference in Go. So normally when you pass a variable to a function, you actually make a copy of that variable. So that's going to be really important here. So when we pass the value to the function, we get a copy of it. We increment the copy, but we don't actually increment the original variable. If we want to actually increment the original variable, we're going to pass it by reference. We're going to create what's called a pointer to that object, and we represent that in Go with this star. So this says x is a pointer to an integer, and then we dereference the pointer to get to the actual integer by saying star x. So here we're going to take the address of the variable. We will then get that variable and add 1 to it. So if we come here, what you'll see is when we call increment by value with 10, it's 10, we pass it in here, we increment it, it becomes 11, but when we get back here, the value is 10. So even though this is named A and this is named A, they aren't the same A. The A in increment by value is a different variable than the A in main. And so the A in increment by value got a copy of the value 10, incremented the copy, and did not change the original. For pass by reference, we sent the address of B. So we sent the address of this 10 to the variable. Then we went through and dereferenced the pointer to find the actual value and added 1 to it. So this picture here may help in thinking about that. So we have a collection of PO boxes, and inside the PO boxes are data. Because this is a 64-bit machine, I've caused the addresses here to go up by 8 bytes, so 64 bits per value. These strings are short, so they can actually fit in 8 bytes. If we had longer strings, it would take up more than one of these boxes. So we have in our box here, we have in X, its value is 42. If we take the address of that variable, it's 1008. And so we say that that points to this variable. So the value in this PO box, so the value in PO box 1072 is 1008, which is the address, the PO box containing the value 42. So that's the basic concept behind a pointer. We'll show you what that looks like by going ahead and running the debugger on this code. So we'll say we want to break in the main program. If that's main.main, we'll continue. So here we are. We can step. Step moves one line through entering functions. So if we step, this actually takes us into the function printf. We definitely don't really want to be in printf. So I'll say step out, which will take us all the way to the end of that function and come back. So at this point, we have printed the value, and we're going to step into the function. Actually, before we step into the function, I'm going to print the address of A. So you'll note the address of A here. It's a long hex number, 64-bit pointer that points to one of the locations in memory. We'll step into increment by value. We'll step a couple times. And you'll see that this value, the address of this A, so its PO box is different. This one was EA8. This one is E78. So the address is lower because as you add things to the stack, which is where we keep local variables, we actually move down in memory. So you would expect in the inner function, the address to be a lower number than in the outer function. So we actually see these two values of A, they're like referring to two different ones of these PO boxes. So there's a different value of A. And so that increment by value, when it gets the 11, when we come back here, that A is unchanged. Now if we keep going a bit, print the address of B, so that's EA0. We step into increment by reference. And you'll see X, that pointer, is EA0, and it's telling us that it points to a 10. So when we step through there, it now points to an 11, and we can come back out. And we see that our value is 11. All right, so that was the command line debugger. The command line debugger had the nice feature that it would let us actually view the values of the variables. There's also a graphical debugger. So we'll look here at swap.go. I have a breakpoint. You can click basically next to lines to tell it to stop there. It actually already ran. We'll go ahead and start debugging. We hit our breakpoint. We now have the ability to continue step over, which is going to go past a function without going into it. We can step into a function. We can step out of a function. We've seen those things before. We can restart, quit, or continue. So I'll go ahead and step over this function. We'll step into swap. So this is a new function here. This is going to again highlight the use of pointers. So we had X and Y, which were 5 and 10. We see now the locals here. So here we don't actually get to see the addresses, but it'll tell us that A is a pointer to the number 5, B is a pointer to the number 10. I want to swap those things. If you think about our PO boxes, if we want to swap the 42 and the 3.14, you kind of imagine those are heavy boxes. You would actually have to take this, put it somewhere else, then move this in here, and then move from here back. So that's actually what we're doing in this swap. We take the value that A points to, we put it in a temporary variable. We then, so temp gets 5, we then take A, we change it to the value 10. So it now points to that value 10. B will now point to the value 5. And then when we come back to the main program, we will see that they've been swapped. So again, one of the key points to understand about functions. So functions allow us to break big programs into smaller pieces. When we pass parameters, those are passed by value, make a copy. If we want to actually be able to change a variable, we need to pass a pointer to that variable. We use the star here to do that. So we say this A and B are pointers to integers. Then star A dereferences the pointer to get to the actual value. So we look here at our picture. So here's an example of a pointer. It has the address of some other memory location. We dereference that to get to the actual value that we want to change. And there you go. That's a quick intro to functions.